Hi everyone, so today we're going to be talking about volume of a sphere. We're going to first start by listing some real life examples. So for anyone who plays sports or just enjoys maybe playing outside, we could start off with a basketball. I know I like to play basketball, maybe a volleyball, maybe a tennis ball. I know I have some tennis players. Maybe a dodgeball. I don't know if you guys even know that game. A soccer ball. We got a lot of soccer girls and boys in here. And then so on and so forth. We could even end with the Earth, because we know the Earth is a sphere. So it says, how many bases does a sphere have? None. Zip. In earth science, did you learn the Earth is a perfect sphere? Of course you did. You learned that it's not a perfect sphere, it's an oblate spheroid. Okay. Then it says, what's the name of the solid below? So this shape, so that doesn't look like the full Earth, it looks like half of it. So that would be a hemisphere. Then it says, what two lines divide the Earth into two hemispheres? It's the equator and the prime meridian. That's right, you guessed it. And then it says, what two hemispheres is North America located in? It's located in the north, so that's the first. Western, that's the second. Hemispheres. All right, moving on. Next page. All right. Says example 1, given a diameter. So at this point, hopefully we've recognized that we never use diameter. We always use the radius. So in class, I know we do a lot of highlighting, so I'm just going to highlight the word diameter with the 12 centimeters, because that's also really important. You always got to look at those units because if they're different, then you know you got to change something. If they're not, you're good to go. So I'm going to start off by taking the diameter, which is the longer word, and chopping that in half and making it the radius, which is the shorter word. So the radius isn't 12, it would be 6 centimeters. I'm going to still include the units. And then as I read the question, it says find the volume. So I'm going to highlight that. It's kind of like a giveaway of what we're going to do. To the nearest tenth of a cubic centimeter. So again, since the units are matching, I'm good to go. I'm just going to plug in and solve. So if I look at my handy dandy reference sheet that I got on Friday, if I was in school, it says volume is 4/3 pi r cubed. And if you weren't in school and you don't have one, that's fine. I'm hoping you guys will have a cell phone. You can always just look it up on Google and you'll see the reference sheet, but I'm giving you the formulas basically in the lesson anyway. So 4/3 pi r cubed, anytime that I'm plugging in, like I'm about to do right now for the radius, you always use parentheses to do it. So I know that the radius is 6, so I'm going to plug that in. On your calculator, you're going to do, when you turn it sideways and you have that big elongated calculator, you're going to do 4 divided by 3 first and press enter. And then you'll times that answer by pi. And then you're going to do times 6 times 6 times 6. Because I got 3 of those. All right. Answer should have been 904.778 blah, blah, blah. But the question says to find the volume, and this is the volume, so I know this will be my final answer, so I can stop. And look, to the nearest tenth, there's 1 0 in the number 10. So I'm going to stop at that first 7, and that's going to round to about 904.8 centimeters cubed, because that's the volume. It's what I was looking for. That was part A. Part B now says to find the volume. So I'm going to just highlight that of the hemisphere. So whenever they name the shape, oops, I skipped that in part A, you should always be highlighting the shape so you remember what formula it is you want to jot down. So I don't want the full sphere, I only want half of it. So I'm just going to take the formula that I wrote in part A for a full sphere and divide it by 2, so I get the hemisphere instead. So I'm just going to take the answer that I got up top, which was that 904.778. Since this won't be my final answer, I need the entire decimal this time. So it was 8 0.6842. That's what I had originally gotten, and now I'm going to divide by 2 because this number here will represent my final answer. So I get 452.389, but I'm rounding to the nearest hundredth, again, of a cubic centimeter. So because all my answers are in centimeters, I don't have to change anything. I'm good to go. There's 2 zeros in 100, so I'm going to stop at the 8. So my final will be 452.39 centimeters cubed. Boom. Number 1 is done. Number 2. Okay, so it says a hemispherical tank, so I'm going to highlight that because it's the shape I'm dealing with, is filled with water and it has a diameter. So I'm going to highlight that again because it's a vocab word, but we never use diameter. We always use radius. So the diameter was 120 inches. Psh, cross it out. That means that the radius will be 60 inches. It's going to be half. Then it says if the water weighs 62.4 pounds per cubic foot, so I'm going to always underline those units, it says what's the total weight of the water. So again, just because that's the question, I'm just going to highlight what's the total weight. All right. There's a lot going on here. I'm dealing with a hemisphere. I had to change the diameter radius. And the question says what's the total weight. As I'm reading this, I'm noticing right off the bat that my units are not matching. I need my answer in cubic feet, not inches. So I'm just going to quickly write on the side that 1 foot equals 12 inches. So as a refresher, if I'm moving from feet to inches, that's getting bigger. So I would multiply by 12. If I'm moving from inches to feet, I'm getting smaller. So I would just divide by 12 instead. So since I'm moving from inches to feet, I'm getting smaller. I'm going to divide by 12. So I'm going to take that 60 inches and divide it by 12 to get 5 feet. So 60 inches is really 5 feet, and now I'm ready to go. Everything is matching. It's in feet. Cubic is a key word. I only find things that are cubed if it's finding the volume. So that's how I know I'm going to find volume in this question. So I'm going to find the volume of my hemisphere. So I'm going to take the volume of a sphere and divide it by 2 because I only want half. So now I'm going to go ahead and plug in 4/3 pi r cubed divided by 2. So I know the radius isn't really 60. The radius will be 5 because we had to change it to feet. And now I'm going to go ahead and type all this in. So you're going to do 4 divided by 3, press enter, times pi, times 5 times 5 times 5, because there's 3 of them. Press enter. And then divide that entire answer by 2. And you should have got 261.7993878. Now the question doesn't ask me to find the volume, so that's why I have to write the entire decimal here because it's not the final answer. So if I want to find the weight, because that's really what I'm looking for, I have to use this conversion. So I know that 62.4 pounds is in 1 cubic foot. The question says, what is the weight? So how many pounds are going to be in this many cubic feet? So 261.7993878. I have to use the entire thing. Now I just cross multiply. My numbers are matching up nicely. So X is going to equal 16,336.2. But it says to the nearest pound, so I have to round here. So I'm just going to keep it as 16,336 pounds because that's what the question was asking me for, and now I'm done. All right, and then example 3, it says a solid sphere. I hope you guys can kind of like see this. All right, I'm moving up a bit. A solid sphere, so again, it gives me the shape, so I'm going to highlight that. It's an entire sphere, has a volume of 36 pi, so all of that's important. And then the question says to find the radius. So I'm going to start off by writing volume of a sphere, formula, which is 4/3 pi r cubed. And now I'm just going to plug in. I know that the volume is 36 pi, so I'm going to replace V with 36 pi. And I'm looking for the radius, and I can see that that's the only variable I have to plug in for. So I'm just going to bring everything down. There's nothing to plug in. And now when I start solving, since pi is on both sides, you would really be like dividing it out. So I'm just going to like cancel it out on both. If you have the same number or the same variable or the same symbol here on both sides, you can just poof, get rid of it. And now I just have to get rid of the 4/3 so I can kind of keep moving here. So I can either divide both sides by 4/3 and then call it a day, or I could multiply both sides by the reciprocal, which is 3/4. That's what I'm going to do just because the opposite of division is multiplication. I just feel like it makes more sense to me. So now these fractions are gone. I just have r to the third, so I'm going to bring that down. R to the third equals, and then again in your calculator, do 3 divided by 4, press enter, and then times it by 36, and you'll get 27. So if I want to get rid of r squared, I would take the square root. If I want to get rid of r cubed, I'm going to take the cubed root. So I'm going to take the cubed root on both sides. So now my 3's cancel out. All I have left is r. So r equals, and the cubed root of 27 is 3. This is actually a function on your calculator that's on your cell phone. If you turn it to the side, you'll see it. So you can practice taking the cubed root at home. So you get r equals 3. All right, moving on. Next page. So example 4, as I'm reading it again, I'm seeing immediately the diameter. As soon as I see diameter, I am like want to just cut that in half because you never use diameter. We always use the radius. So half of 9.5 is 4.75. I know that it was in inches, so I'm going to keep that. It was in inches. Then I continue reading. Now it's telling me that the diameter of a tennis ball is 2.5 inches. But again, I don't want the diameter. I want the radius. So half of 2.5 is 1.25. And again, it was in inches, so it's 1.25 inches. So this is good. My units match. And then it's just asking this kind of like weird question. I don't think you've seen this wording yet. The volume of the basketball is how many times greater? I'm going to underline that. How many times greater than the volume of the tennis ball? So it's really asking like how much bigger is it? But instead of saying like how much bigger it is using addition or subtraction, you should be thinking multiplication or division. So I'll come back to that in a minute. First, in order for me to see how many times greater it is, I have to find the volume of the basketball and the volume of the tennis ball. So I'm a lunatic. I'm just gonna be crazy with my work here, organize it and label everything. So I have to read into the question. Since I know a basketball and a tennis ball from the Do Now are both examples of a sphere, that's the volume formula that I want to copy down from my reference sheet, and that's 4/3 pi r cubed. Then I'm going to set myself up here for the tennis ball as well, which is also 4/3 pi r cubed. And now I'm just plugging in the radius, which I already found on both. Good to go. So the volume is 4/3 times pi parentheses, because I'm plugging in. So the radius for the basketball was 4.75. And I know that the radius for the tennis ball was 1.25. And then, like I already kind of helped you out how you would type all these in the calculator. This is just another example. You do one little thing at a time. You should have got the volume to be 448.9205002 for the basketball. Tennis ball should have been 8.181230,869. And since I want to know how many times greater, is it 1 time greater, 2 times greater, 3 times greater? Even as I'm answering the question times, is it 3 times greater, 4 times greater? I'm not going to multiply these. I'm going to use division to figure out how many times greater that number would have been. So I'm going to do 448.920 5002 divided by 8.18, blah, blah, blah. I have to use the entire decimal since this is not the final answer. And then when you divide it out, you should have got 54.8719, dot, dot, dot. But again, is it like 2 times greater, 3 times greater, 54, or 55 times greater? So I want to round to the nearest whole number. The 8 tells me to round up. So it would be about, that's like the approximately symbol. It's like 2 squiggles. So it's about 55 times greater. All right. And then last but not least, I know this has been a little bit of a roller coaster here. It says the greenhouse pictured below can be modeled as a rectangular prism. I'm immediately going to highlight the shape since they're giving it to me. And it's also being modeled with a half cylinder on top. I'm going to highlight that as well. So I have 2 different shapes here. The rectangular prism is 20 feet, 12 feet, and 45 feet. So that's the length, width, and height. They're all in feet, so that's good. The half cylinder, again, says it has a diameter. We don't like diameter. We want to cut that baby right in half. Half of 20 is 10. So I know that the radius is really 10 feet, which is still good. All my units are in feet, so that's awesome. Now I want to find the nearest cubic foot. I'm going to underline that. Cubic tells me to find volume. Feet or foot tells me that all my units should look like that, and they do. They're all in feet. So if I want to find the volume of the entire shape, I'm going to take both and then add them together at the end. So I'm going to start off by writing the formula for volume of a prism, which is capital B times H. Just as a refresher, capital B is not base. It represents the area of the base. So if I look back, it's a rectangular prism. So I know that the base is a rectangle. So how do you find the area of a rectangle? That would be length times width. So I'm replacing capital B with L and W, and then H just comes down from the formula. Now I'm going to plug all 3 in. So the volume would be 20 times 12 times 45, and then you get 10,800 feet cubed, because I know this was in feet and I'm finding the volume, so it's cubed. That was just for the bottom. Now I'm going to find the volume of the top, which was a half cylinder. So when you go to your reference sheet and you find the volume of a cylinder, it's pi r squared h. But I'm only finding half of one, so I have to divide it by 2. So now when I come here and I try to plug in, I have pi r squared h divided by 2. I know that the radius is really going to be 10 feet, so r is 10. And then the tricky part here is the height. So I'm just going to have you finish outlining the entire cylinder here. I think it's going to help notice what number represents the height. Some of you are probably thinking it's 12. Some of you might think it's 45. The answer is actually 45. I'm moving from like the top of my soup can to the bottom of my soup can, which is way down there, not like below. So how do I get from the front to the back? I'd have to follow this line segment, which was 45. All right. So again, I'm going to type the whole top in, press enter, and then divide it by 2. So when I do that, you should have got 7,068 point, and I'm going to include all of those numbers after the decimal because, again, this is not my final answer, and this would have been feet cubed. So now I'm going to take the volume of the bottom, I'm going to add it to the volume of the top so I can get my entire volume, which would be 17,868.5. But the question says to the nearest cubic foot. So I have to round to the nearest whole number, which would round up. It would be 17,869 cubic feet. All right. Miss you, love you. Don't forget to do your homework. It's on the last page. Okay, do your best. Use the reference sheet. Hang tight. Talk to you soon.